Hi, dear students. In this series of episodes, we have been trying to understand the fundamentals of vectors. Let us take the topic forward. Today, I am going to discuss about coplanar vectors. So, what is a coplanar vector or coplanar vectors, I must say? When I have two or more vectors, and if all the vectors can be aligned on a single plane, two-dimensional plane I say, then I call all these vectors collectively as coplanar vectors. I said two or more vectors. So let us look at here. Let me say this is a vector, say this is vector A, and say this is another vector B. Now, I see that I can have these two vectors in a plane. As such, the two vectors can be placed on a plane. I would say that these two vectors are coplanar vectors. When we look at these two vectors, one thing we can understand that any two vector can be arranged in a plane. Any two vectors can be arranged in a plane. That means always two vectors are coplanar in nature. But what about if we have more than two vectors? So if I have three vectors, then these three vectors can be coplanar or cannot be coplanar. I would say that three vectors may be coplanar or may not be coplanar. Next, let's have a look at the angle between two vectors. What do we actually mean by angle between two vectors? Let me say this is vector A and this is vector B. Now, to find the angle between two vectors, in the last classes we have seen that we have a freedom to shift any vector parallel to itself. So as such, let me suppose that I am going to shift this vector parallelly here. So let me say I have shifted this vector in a parallel direction. Now when I look at these two vectors, one thing I understand that the tails of the two vectors are coinciding at a point. When the tails are coinciding, then I see that the vector A and vector B subtend some angle here, and if I look at here, this is also another angle. Now, when I have two angles, I must choose the smaller of the two angles. In that case, this is the angle between vector A and B. So to find the angle between two vectors, the first rule is that we must shift the vectors in such a fashion, we must arrange the tails of the two vectors to coincide at a point. Other way around also we can see. See, I can also do the other way. I have shifted vector A in such a fashion that the tails coincide. I can also shift vector B in a parallel direction, and I can make the two heads of the vector to coincide at a common point. In that case, again I get two angles. One is this angle, the other one is this one. So two angles, smaller of the two angle will constitute the angle between two vectors. So for me, the angle between two vectors is this one. And when we measure these two, if I shifted the two vectors in a parallel manner, then in that case, these two angles will measure equal for me. Let us try to understand the concept of the two vectors. Now let me suppose that I have one vector like this. I say this is vector A. Another vector is like this, say B. Now these two vectors are oriented in such a fashion, the tails are coinciding, so it satisfies the condition for me to see what is the angle between the two vectors. So this is the case. Now let me suppose that I am going to rotate this vector B in this fashion. So see please, let me say I have rotated this one. Of course, the direction has changed. So therefore, the two vectors B do not remain same. So since direction has changed, magnitude is equal, so I have written B dash. I see that now the angle between the two vectors has increased. That means when we rotate B, this changes to B dash, the angle has increased. Now if I rotate further, I'll see that again, see the angle is increasing. Because this is one angle and this is the other one. This angle is greater, this is smaller. So I will consider the smaller angle as the angle between the two vectors. Further, if I rotate the vector, so this one, I see that again, this is the angle between the two vectors. Further, if I rotate, then this is the angle between the two vectors. So now I have arranged the two vectors in such a fashion, say this way, the two vectors now are collinear. A, B double dash has become collinear. So the angle between the two vectors is 180 degree. Now if I try to further rotate this one, B, so I have further rotated. Now if I look at, see the angle is this one and this one. I am going to look at the smaller angle. So smaller angle is this one. So this time for me angle becomes between A and B, this angle. So when I look at this picture, one thing I understand that the maximum angle between two vectors can be 180 degree, not more than that. Because see, with respect to B double dash, if again I rotate this one further, now the angle is less than 180 degree. So the maximum angle between two vectors can be 180 degree. Okay, in other case, let us suppose that I have two vectors, say this way, this is A and this is B. So what is the angle between the two vectors? The angle between the two vectors, see please, if I shift this one, A, and if I try to coincide on vector B, I have represented by dotted line to show it separately between A and B. So in that case, see please, the angle made between them is 0. That means whenever I have two vectors parallel to one another, then the angle between the two vectors is 0. And we call these two vectors as parallel vectors also, that we have studied earlier. And if I have a vector like this A, say, another vector I have B like this, magnitude need not be same. So let me say this is vector B. The direction is opposite. We already studied that these two vectors are anti-parallel. So the angle between two anti-parallel vectors, I would shift this vector in a parallel direction. I see that this is vector B for me now. Now tails of the two vectors are coinciding and the angle between them is 180 degree. So therefore, two anti-parallel vectors will constitute or subtend an angle of 180 degree. Two parallel vectors together subtend an angle of theta is equal to 0. And also we saw the fundamental that the angle between two vectors can have a maximum value of 180 degree. Also, if we have two vectors like this, let us say this is vector A, and say here I have vector B like this. Say this is vector B. Now I see that the tail of vector A is coinciding at the head of the vector B. But to find the angle between two vectors, I need to make the tails of the two vectors to coincide at one point. So therefore I am going to shift this vector B in a parallel direction. Say I have shifted like this. So this is also B for me. And as such, the angle between the two vectors are 90 degree. And when two vectors make 90 degree, we also say that the two vectors are orthogonal. The two vectors are orthogonal. Let us try to solve some problems so that we can identify the vectors between the angle between the two vectors, let us say. So, say I have a vector like this, say this is vector A, and I have a vector like this. Say this is 60 degree. and this is vector B. So find the angle between two vectors. Find the angle between two vectors. So what's it? The general rule says that the tails of the two vectors must coincide, but here we see that the head of one vector is coinciding on the tail of the other. So let me say that this is vector A and this is vector B for me, but this time I'm going to parallelly shift the vector in such a fashion that the tails of the two vectors coincide, and when the tails of the two are coinciding, then the smaller angle between the two vectors will constitute or subtend the angle. So if I go this way, do you think that if this is 60 degree, then this will also be 60 degree, alternate angles? So thus the vector A and B subtend an angle of 60 degree. Let's have one more example. I say this is vector A, this is vector B, and I say this is, say, 120 degree. The question is, what is the angle between the two vectors? Again, we follow the general rule. See, we will shift any one of the two vectors such that the tails coincide. I have shifted this vector B. Now the tails are coinciding, then this will be the angle. So if this is the angle, I see that the entire angle is, theta is equal to, see, 120 degree this one, so the total angle is 180. So shall I say 180 degree minus 120 degree? Will this be equal to 60 degree? So thus the angle between the two vectors here between A and B is 60 degree. Let's look at another example. Say I have a vector, this is this is 40 degree. Say this is vector A and this is vector B. I am asked to calculate the angle between the two vectors. So I see that head of A is coinciding at the tail of B. As such, I will shift the vector here. So this will be A again because I have shifted the vector parallelly, and therefore the tails are coinciding. The smaller angle between the two vectors is this one. So this will constitute theta. So for me, theta is equal to 180 minus, I will subtract this one. This happens to be 40 degree. Otherwise, the angle constituted by the two vectors A and B is 140 degree. Let us look at another example. Say I have a vector like this, I have a vector like this, and I have a vector like this. Say this constitutes 60 degree, this constitutes 50. So 60 plus 50, 110, let us say that this constitutes 70 degree. And shall I say this as vector A, this as vector B, and this as vector C. I have to calculate the angle between vectors A and B. I have to calculate the angle between B and C and A. So if I go by the rules, I see that, let me try to find what is the angle between A and B. So to find the angle between A and B, I see that the head of A is coinciding with the tail of B. So I will shift the vector A here. So I see that the now tails of A and B vector are coinciding. So the smaller angle is this one, and this will be 180 minus 60, which is going to be equal to 120 degree. That means the angle between vector A and B, I say the angle between vector A and vector B, say like this, angle between vector A and vector B is 120 degree for me. Then when I see between B and C, the rule says that if the heads of the two vectors are coinciding, then the smaller angle will be the angle between the two vectors B and C. So as such, the value is directly available. So therefore, angle between, I say, vector B and vector C is 70 degree. Next comes the angle between vector A and C. Again I see that the tails of A and C are coinciding. So this is the rule, and the smaller angle, so this angle is directly visible for me from the figure itself. So the angle between vector C and vector A is 50 degrees, say. So these are the angles between the vectors AB, BC and CA. This is how we need to find the vectors. Let us try to see another example. Say I have a vector like this, A. Say this is a vector B and this is a vector C. And let me assume that the angle between these two vectors, or say this constitutes 120 degree and say this constitutes 150 degree, 50 degree. I have to find the angle between, vector A and B. Similarly, I have to find the angle between vector B and C. Also, I have to find the angle between vector C and vector A. Now, if I go by the first one, angle between A and B. So let me name this one. This is vector A, this is vector B, this is vector C. So A, B, rule is tail must coincide. So the tail of B and tail of A are coinciding. So therefore, do you think that the angle between them is 120 degree? Yes. Next, if I see for angle between B and C, the head of B is coinciding with the head of A. As such, what I am going to do is I am going to parallelly shift one vector such that the tails are coinciding. So this is B for me, and the smaller angle is this one. Total is 180 degree. So I will have 180 minus 150 is equal to 30 degree. So this is going to be 30 degree. Rather, the case is we have to find the angle between vector C and vector A. To do that, I am going to shift this vector here such that the tails of the two coincide. If I do so, see please, C, shall I bring here? So if I bring here C, so see this angle is 30 degree. So shall I say this angle is 30 degree? This is 30 degree. Because the rule is, see, the tails of A and C must coincide. I have shifted the C in a parallel direction such that the tails are coinciding. So first rule is obeyed. As such, I see that this is 30 degree. So here the tail of C and B also coincide. The smaller angle is 30 degree. Now this A, vector A makes 120 degree with this one. So I would say that this is total 180 degree. So if I subtract from 180 degree this 120 degree, do you think that this will be 60 degree? This will be 60 degree. I redraw the diagram now to have a legible view. So therefore, this is my vector C. And this is my vector A, and if this is 60 degree and this is 30 degree, to me, to calculate angle between vector C and vector A, the two tails are coinciding. So the smaller angle, this must be the angle. So total angle is 180 degree. So shall I say 180 degree? If this is theta, then this is equal to 60 degree plus theta plus 30 degree. Otherwise, from this I calculate theta is equal to 90 degree. So the angle between A and C is found to be 90 degree. Right? Let's see another example. Let me suppose that I have a square. And on this square, let me suppose that one force is acting here. Say this is force F1. Force is a vector quantity, as we have studied in class 9th also. And I say the angle made by the vector, let us assume that this is 45 degree. And on this square, one more force is acting, say in this direction, it is F2. And say this is 30 degree. Now we are asked to see what the vector f1 subtends an angle with vector b, I mean f2, say. So what is the angle? What is the angle between f1 and f2? So thus, to see what is the angle between the two, what I am going to do is, let me draw this vertical side, this arm I have represented like this. So to me, my f1 is like this, and we said that this is 45 degree. What I am trying to do is, I am trying to shift the two vectors in such a fashion the tails of the two vectors will coincide. In that case, shall I shift this vector here? So if I shift that vector here, so rather, instead of drawing like this, let me also draw one horizontal line that would represent this side as such. See, this is the vector, and with this side it makes 30 degree, so here it makes 30 degree. Right? Now, the first rule is satisfied that the tails of the two vectors f1 and f2 are coinciding. Now, the angle constituted will be this one. This angle will be the angle between two vectors. In that case, see please, I can see that this is 90 degree. So if this is 45 degree, do you think that this will be 45 degree? This angle will be 45 degree. Now if this is 45, this is 30, so total angle comes out to be 75 degree. So thus the answer is the angle between vector f1 and f2 is 75 degree. So this is our answer. Let's have a look at another problem. The problem says the angle between vector A and B is, say, 60 degree, and angle between B and C is, say, 50 degree. Then the question is, what are the possible angles between A and C, vector A and vector C? This is the question. Okay, so let us try to see. Let me say this is vector A and vector B. Shall I say like this? And says that the angle between them is 60 degree. And the angle between B and C is 50 degree. In that case, this is vector B for me. So the angle between, so the tails of B and C will coincide. So the tail can coincide like this. So let me say this is, say, this is 50 degree. Okay. Now, this is one case. Now the question is, what is the angle between A and C? In this case, I see the angle between A and C, so the tails of the two are coinciding, so the sum of the two angles. So here, the angle between A and C is, it comes out to be 60 plus 50, which happens to be 110 degree. If I see in the other case, let us see here, this is vector A, this is vector B, the angle between them is 60 degree. Now the angle between B and C is 50 degree. Instead of having vector C below, let me have the vector C above B. So shall I say like this, I can have vector C, and I say that the vector B and C constitutes 50 degree. And in this case, the angle between A and C happens to be, see, you subtract 50 from 60. So therefore here the angle between vector A and C is 60 minus 50, which happens to be 10 degree. So here this is 10 degree. So now question is, what are the possible angles between A and C? So we look, here it is 110 degree and here is simply 10 degree. So only these two angles are possible, or more angles can also be possible. Let us try to see. This is my vector A. This is my vector B. Vector C I had here in the first case, and in the second case I had my vector here C. But just imagine, if I have A, B, C, this is 110 degree. If I have C here, I say that it is 10 degree. I can also have, see, the angle between B and C is 50 degree. I can rotate this C angle like this, keeping the 50 constant, angle 50 constant. So this vector C will carve out a cone. Okay, so thus, see, when I rotate this one and when I bring here, so the angle between A and C varies from 110 degree to 10 degree. I hope you understand now. This is vector A, this is vector B. C makes 50 degree with this one. I am going to rotate C around B such that, see please, when it comes here, it makes 10 degree. So when I rotate from 110 degree this way, the vector C, and when it comes here, it makes 110 degree. That means the angle between vector A and C can be all possible values of angle between 110 degree and 10 degree. Therefore, the question was, what are the possible angles between A and C? See, the possible angles are, any angle between 110 and 10 degree. So this is the answer for this one. Let us try to have a look at another concept. When I try to multiply a vector quantity with a scalar quantity, then what the result would be. So multiplication of a scalar with a vector. So if I look at this scalar quantity, what it can do? Number one, the scalar quantity can change the magnitude of the vector. It can change the magnitude of the vector. Second, what it can do, multiplication of a scalar can change the direction of the vector also. It can change the direction of vector. Third, what it can do, it can change the unit of the physical quantity. It can change the unit of vector quantity. These three things can happen when you try to multiply a vector with a scalar. Let us see example. For the first part, if I look at, let me suppose that I have a vector A, and I want to multiply this vector with a scalar quantity, say 2. So when I multiply it with a 2, so this is going to become 2A. When I say 2A, 2 is a scalar quantity multiplied to a vector A, that means the magnitude of the vector A becomes twice when you multiply with a scalar quantity 2. So therefore, if I draw this vector, this will be like this. So magnitude of this vector is twice this vector. So this is the result of multiplying a scalar quantity to a vector 1. Let us take another example. Instead of multiplying 2, let me say that I want to multiply this vector with a scalar quantity 0.5. In that case, see please, this vector will be 0.5a. So this is another new vector. New vector, what it happens is, see, the magnitude, the length of this vector will be half of this one. and that's what we mean. When you multiplied a scalar quantity, it has changed the magnitude, and this is what the point 1 says. The second point when we look at, we say change the direction of a vector. So let me suppose that I have the same vector here. So same vector in the sense I can shift this vector in a parallel direction. So say this is vector A. Now instead of multiplying this vector with a 2, I want to multiply with a scalar quantity minus 2. In this case, the magnitude is of course equal to twice the magnitude of this one, but this minus sign will make the result to have a direction in the opposite direction. See, previously when you multiplied plus 2 with this vector, you had the same direction, but this time when you multiply minus 2, the direction of the resultant vector accepts or has opposite to the direction of vector A, and this is what we say change the direction of vector A. So multiplication changes the direction of vector A. If that is the case, then question arises, if we multiply with minus scalar quantity, the direction is exactly opposite. Question is, next, is it possible to have, by multiplying a negative scalar quantity to a vector, any other direction? No. Exactly, when we multiply a negative scalar quantity with a vector, the direction of the resultant vector will be anti-parallel to the parent vector. This is what it means. Let us look the example for third point. The multiplication of scalar with a vector quantity changes the unit of a vector. Right? So say this is force F, which is a vector quantity, and let me suppose that then this will have a unit called Newton. We are aware of. Let me suppose that with this force I want to multiply a scalar quantity, say 2 meter. I want to multiply a scalar quantity, say 2 meter. So when I multiply this 2 meter with this force that has a unit of Newton, the result is going to be 2 times of F Newton meter. So thus when you look at, see, this force had, or this vector had unit Newton, but when you multiplied a scalar quantity to a vector, you find that the resultant, of course the result will have twice the length of this one, but the unit has undergone a change. This is an example that when you multiply a scalar quantity with a vector, then it changes the unit of vector. So dear students, let us wrap it up this session, and in the coming session let's look at some other new concepts. Thank you very much.